Okay, so continuing with example 4. With the function shown at right, draw rectangles forming the left-hand sum shaded in blue. I have pink, and I want to follow the rules. I don't have blue. So it's going to be green. So we're going to calculate the left-hand sum. Let delta x equal 2. What does that mean? So delta x equals 2. What is delta x? Delta x is the width of each rectangle, right? So we want then this right here to be delta x. Okay? So that's the width. So when we calculate this area, we'll be multiplying by 2, right? When we multiply the width, okay? But I have these 1, 2, 3, 4. I have these 4 dots right here. We're going to calculate the left-hand sum. So we're going to basically draw, this. Actually, I should be, let me use ink, actually, so it'll be blue ink. So if I do this, what I need is, I need the left top of the rectangle to hit the curve, okay? So the way that this would actually look is that if I go here, if I drew a rectangle right there, can you see how this guy would actually be the left side of the top of the rectangle? Okay, and remember I'm going to width of 2. Okay, this is a left sum here. Now because this guy is decreasing, this function, the left Riemann sum is actually going to be an overestimate if I keep this going. Okay, so here's the left. Here's one rectangle. Okay, now with a delta x of 2, I go here, move over 2, go down. I go here, move over 2, go down. And then you can see that this is a very big overestimate. Not so much here, but this here, there's a big decrease here, so that's a definite overestimate. But you can see that I end up getting, well, I don't have enough information here. So it looks like that's all that I really have. Now technically, I should go all the way to here. Okay. But I'm actually going to stop right there. I don't see anywhere where it says how many rectangles, but it looks like we're going to basically ignore that guy right there. Okay. Okay, so now at this point, what we have is I have a left-hand sum of 3 triangles. Okay, a left-hand Riemann sum of 3 triangles. That's what that 3 stands for, obviously. And what we're going to do is we're going to add them up. So what is the area? I have areas of 2 at each time. So if I go to 8, then I have 7, then I have 5. So 8 times 5 times 7. Okay. So I'm basically doing the width times height, width plus width times height plus width times height. Okay, so I've got, let's see, that's going to be 20, that's going to equal 40. Okay. All right, now we can definitely see this and see that this is definitely an overestimate. Okay, but this is 40 square units, and it's an overestimate. Now I'm going to use the same one, and I'm going to do the right-hand sum. And I'm going to change the color on this guy. Now the right-hand sum means that what I have to do is I have to make sure that the rectangle, the right top of it, the upper right-hand corner of that rectangle actually hits the curve. So that's going to cause me to do this. Okay? So you see how the switch goes. If I use the left, I'm going to be over top of it. If I use the right, I'm going to be under it. Now that's going to change if my function actually increased. It would be the other way around. It would be vice versa. So here I have this one. There's my next one. And then finally this one. Now this will be a big underestimate. Okay? So let's do right hand 3. Okay, again I still have a now remember, I'm doing that whole summation formula actually, that that complicated one on the second page. I'm adding up all the rectangles. That's exactly what that formula is saying. Now I have a width of 2, and I'm going to multiply to 7, 5, and 1. So 7 plus 5 plus 1. So what I'm doing is I'm basically taking the height of every single one, and I'm going to distribute the width 2 to each one of these, add it all up. That's 14 plus 10 plus 2. You probably could have did that in your head. That ends up being 22nd, and that is probably a gross underestimate. Okay. All right, now we already answered C by labeling the overestimates and underestimates, so let's go to D. But now what we've done is we're going to actually change our delta x to 0.5. Okay, so you can see here though that we've got 0.5. They've actually gone 2 units here, but see the difference is that we are not going to have 2 units here. We're going to have a 0.5 because the width is actually smaller. So let's do the left hand. So left hand, how many are we going to have? 1, 2, 3. We're going to have 3. So left hand means I need the left. Now this guy's increasing now. So notice what happens is the left. I need the upper left hand corner of that rectangle to hit the curve. So he's going to go there. Right there. Goes up to here. So now the left hand has switched. Now it's going to be a big underestimate. Okay. Now because that width, I'm going to actually write this a little differently. Let's go 1 times 0.5 for this first rectangle. Then this width is also 0.5, but I've gone up to 4. Okay, you can write it like this. This up here was kind of a shortcut. Then I'm going to add the height here, which is 6, and then I multiply by 0.5. Okay, I'm going to add them all up. So I get that's 0.5, this is plus 2, and that's 3. So this ends up being 5.5. And we didn't write units. Oh, yeah, we did. Units squared, units squared. Okay, now we're going to go ahead. That's step A. So when we do B, we're going to go ahead and do the right hand limit with 3. I'm going to change color. You can see that the right hand actually goes like this. Okay, so now this guy would be the overestimate, okay, and this guy would. Now this actually requires a little bit of practice. I might be making this look a little easy by drawing the right and left, but you kind of have to like get a feel for it to be accurate, because it's not probably maybe not as easy as what I'm making it look right now. But notice what's happened is we still have the delta x of 0.5, okay, but the height is larger, okay, so now I got 0.5. So you can see that the right hand Riemann sum is actually going to be an overestimate. So I go 4, then I go 6, and that's going to be also delta x is 0.5, and then I go all the way up to 7, and that would be 0.5 as well. So when I add these up, that's 2 plus 3 plus 2, that's going to be 3.5. So you can see that that's actually 8.5 square units. Okay, so a big difference between these two. All right, big difference. And so now we'll move forward. What are we at? We're at 8 minutes now. Okay, so let's think about this carefully here. This guy right here, this was a concave down, and what we can do is we can kind of use the logic. You can see kind of concave down, right? It looks, it's a cup that's being emptied, okay, poured downward. This guy's also concave down. I feel like we should draw pictures for these. Okay. But this one is decreasing. Okay, so let's do this. Okay, increasing concave up would look like this. Decreasing concave up would look like this. Okay, right here, concave down increasing would look like this. And for decreasing concave down, it would look like this. And what I'm doing is, what I'm really doing is I'm drawing a little curve so I can figure out what are my left and right hand sums. Are they going to be over or under for each thing? Okay, so I got my little shapes. All right, so let's see. I'm going to draw both here. If I'm a left hand here, if I'm a left hand, all right, that means that the left part of this, okay, the left part would have to look like that, right? So if this guy is the left hand and this is an increasing concave up, you can see that this is clearly an underestimate, right? Okay. Now, by extension, if it's the right-hand sum, it has to be an overestimate. Like, it has to. Unless it's a constant function, unless it's actually like our very first example, like this. Okay, that's exact. All right, that's an exact area. But here, with these estimates, okay, this has to be an over. All right, there's just no way around it. Okay, now let's look at the left here. All right, so if I have the left, you can kind of see that my rectangle would again be under the curve. So my left hand would be an under. Okay, and my right hand, which, you know, I'll just kind of prove to you, if it was a right hand, it would look like that. Okay, so then that would be an overestimate. So that's over. But again, if you figure out that the left is under, then the right has to be an over. All right, so you can probably understand that this is going to flip-flop. So let's go this way. If we have a left, you can kind of see that that would be an overestimate because I'm touching the left top of the rectangle. It would be over. So that makes the right an under. All right, now if I have a left here, okay, you can kind of see that that would also be an over, and the right would be an under. Okay, so it kind of helps to just draw these little pictures rather than have this memorized. It's good to kind of understand what's happening. All right, and then finally, for our last example here, it's a big one. All right, and so we are not doing, we're doing midpoint and trapezoidals. Okay, now that I feel like should be a separate video. Okay, so let's do numbers, let's do example A and B. All right, let's do example A and B. Oh man, my blisters look so gross. The table below represents the velocity v of t in feet per second of a car traveling on a straight road over a 50-second time interval. We want to estimate the distance the car has traveled over this interval using right-hand and left-hand sums, along with two different approximation techniques, the midpoint and the trapezoidal rules. All right. Now the trapezoidal rule is actually very simple. The midpoint is kind of simple as well, but you know, we'll talk about, we'll actually do the midpoint and the trapezoidal video tomorrow. Okay, then I will actually look at your homework to see which question. Just essentially, if it says midpoint or trapezoidal, just skip it. Okay, so you can actually do your as part of your homework tonight. All right, if you so wish. All right, so the total distance traveled by the car. Now I'm going to use two different colors here, and we're going to use a left-hand sum first. So we want 5 partitions of equal length. Okay, so this is convenient though. The 5 partitions looks like we have 10 seconds, 20 seconds, oh, it goes right up to there. Okay, so we only want to use these blocks here. Okay, so you can see like our width. We want 5 partitions, and in our head we can see that we're going to have 1, 2, 3, 4, 5. We're going to have 5 rectangles. Okay. So, and each will have a delta x of 10. Okay, so our delta x here will be 10. Okay, so let's go ahead and draw them in blue. Well, mine's going to be green. And we'll do the left-hand sum. So left-hand sum means that the left-hand portion has to touch the curve. The left-hand portion, in this first instance, is actually right here. Okay, that's where it touches the curve. So what we have is we have a height of 0. So this guy we will not actually include, or we can, but he's just going to be 0. Okay. Now the next one will be here. Okay, and we're going to move over 10, delta 10. Okay, that's our next one. here, this guy will actually go there. We'll move him over to here. Then this guy will go from here to here. Then we will go from here to here. So notice that this guy is now, it's not just plain and simple that this guy is an over and underestimate, because he's kind of changed directions. So we're actually we're at an underestimate up to here, but then over there became an overestimate. Now, will these balance out? Probably not. This overestimate is significantly smaller than these underestimates. Okay, so we can conclude that this is going to be an underestimate. But again, we're going to use this table to actually calculate what those areas are. Okay, so the left-hand sum at 5, okay, will be delta x times all of those heights added up. So the height, the first one is 0. And then it looks like at 10, we're actually at 20. And then at 20, we are at 52. Then at 30, we are at 80. At 40, we are at 77. Okay, so we needed the table for that one. And then at 40. Okay. Now, can you actually see what happened was is at 40, when I went to 40, that gave me the rest of it. Okay, so what happens is that when you have a left-hand sum like this, what will happen is you're going to use 5 triangles, but you're not actually going to, oh, never mind. What am I trying to say? I'm jumping ahead of myself. Okay, so 0 and then all these heights. Let's just add it up. All right. Now we do that calculation. We should get 10 times, I'm looking at the answer key over here, 229. And that's feet, so then our final answer is going to be 2,290 feet. Okay, that's a left hand. So that's how far the car traveled. Now if we do it the right hand way, I'm going to change colors. The right hand means that I need the right hand here. Okay, so you can see that that's going to be an overestimate. The right hand here would go to here. The right hand here is here. The right hand here is there. Okay, I'm actually going to draw over these now. Then the right hand here is there. Okay, so the right hand of 5 equals delta x of 10. But now we don't have 0 value here. We actually went all the way up to, it looks like 20, right? Yep, 20. Now I'm going to add, what is that height there at 20? 52. Then I'm going to add, at 30 it was 80. At 40 it was 77. And then at 50 is actually 74. Okay, so again, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So you can see that this guy is the under, this guy is the over. Okay. I mean, it's kind of clear by the drawing as well. So if I added all those up, it's going to be 303 feet. So that's going to give us 3,030 feet. Okay. Now, you know what? I might as well just tell you, since we're 18. Okay, that's fine. The trapezoid. Okay. The trapezoid is basically going to be the average of these two. You add this up, divide by 2. That's the trapezoid. But I want to draw the picture of it. Okay. Now, the drawing of the picture, now here you can see that this is the midpoint. Okay. Now the midpoint, this is letter C. You know what? Gosh, we can do midpoint. Let's just squeeze it in, just knock it out. And then that way you don't have to watch any more videos for the next couple days. All right, the midpoint here is, what has happened is that we're not going to go from 0. We're not going to have a left and a right here. What we're going to do is we're going to actually go right in between. Now, the average of that would create a trapezoid. Okay, between the left and the right, we're going to create a trapezoid. But let me actually show you what that would look like. And I'm going to use dark color. No, let's use orange. Okay. Now the trapezoid going to look like this. I basically draw the left and the right, I draw a line right up to it. Now in this case that's a triangle, but this one to this one, you see how that's a trapezoid? That's a trapezoid, okay? If I draw this one to there, that's a trapezoid. This one to here, trapezoid. And then this one to here, trapezoid. Now can you see that the trapezoid is much more accurate? It is. Because what the trapezoid allows you to do, okay, the trapezoid, we'll call it TS, the trapezoid sum with 5 partitions is basically the left hand sum plus the right hand sum divided by 2. Okay? And that is basically averaging, okay, the heights. Now it's not the midpoint because the midpoint is something else. In fact, the midpoint, we're going to actually have to go back to these tables. Okay? So that is very easy to calculate, the trapezoidal sum. Okay? And is much better than the left and the right. Okay? It's always better. So what we'll do is we'll add those two. We'll go 2,290. Actually, yeah, that's right. And then 3,030 divided by 2. And we actually end up, my answer key, let me just verify this, 290 plus 3,030, okay, divided by 2. I get 2,660 feet. Okay, pretty beautiful. It's great. And what it does is it creates a trapezoidal. So basically cuts the over and the under, kind of like it just averages it. Okay. But the midpoint, which I'm going to do yet in another color, is actually this shaded region here. And actually, I'm going to save this guy as a pure midpoint. You can see that I still have a delta x. Okay, let's label this the midpoint because he's going to be his own separate picture. Okay. Because the trapezoid uses the left and the right hand. The midpoint, you can see that it's actually, the delta x is still 10. Okay, it's still 10. But my height is actually in between 0 and 20. Over here it was 0. This guy was 20. But the midpoint means that I want to actually find out the value in between 0 and 10. And we actually have a table that has it at 5. So I want to go 14 high. We didn't use these middle numbers here at all in our left and right hand sums. But for the midpoint we will. So we're going to go right in the middle between 0 and 10, right in the middle between 10 and 20, and so on and so forth. So what will happen for a midpoint sum and 5 rectangles here is going to be the delta x of 10, but now I have different values. I've got better values. I've got 14, right? 14. I don't want to zoom out, it might shut off. Let's see, 5 is 14. Okay, plus the midpoint here at 15 is 28, so that's actually right there. Okay, so we'll put 28. The midpoint here is right there. Okay, so you can see that the midpoint is an over-under, right? It's neither an over or an under kind of. It like really finds that sweet spot. And 28, where are we at? 25. Okay, 70. Oh, I think we got a delivery. I think that's my Xbox. 35 is 86. I'm expecting it tomorrow, but I think it's coming today. Yay. Midpoint there. Okay, midpoint at 45 is actually 70. Okay, ladies and gentlemen, that's it. We've essentially got Riemann sums. I think that's Atticus probably freaking out. He cannot wait to play Hello Neighbor. Oh my gosh. He's been asking me all day. 2,680 feet. Okay. And then again, E, what did this mean? When you took the averages of L5 and R5 and compared it to here, they're identical. Okay. So if they ever ask you on the AP exam, use trapezoidal sum, take the left, right, averages. So much easier because I have seen actual textbooks have a formula for trapezoidal and it's ridiculous. It's a ridiculous formula. So if you just find the left and the right, very easy to do. Take the average of the two, and you've got your trapezoid. Okay, midpoint is you just need to know what happens in between. You need a value here in order to make it work. Okay, now if you had a function, then you would have to plug that number into the function to see how high it is. But unfortunately today we have a table. All right, so that's pretty much it for Riemann's sums. So on Friday is where we'll kind of have our question answer thing. Feel free to email me questions if you want to. You know, we can do whatever. If you need any help, just, you know, I'm around. And I will not make the next section videos probably until Wednesday. Okay? All right. Have a great afternoon, everybody. Good evening.